Hello and welcome to Starlim's first webinar of 2024, Enhancing Experiment Efficacy with an Electronic Lab Notebook, featuring our very own LabStep ELN team, Jake Schofield and Barney Walker. In the fast-paced world of R&D, leaders face a myriad of challenges, from volatile market and geopolitical landscapes, regulatory changes, to the ever-growing pressure to innovate quickly and cost-effectively. But manual paper-based data collection methods are stifling innovation, while siloed systems slow productivity and introduce data quality and traceability issues. We're super excited that you have joined us today to explore the history of scientific documentation, the importance of data quality, and the benefits of using modern ELN technology to advance innovation. Here's the agenda for today's webinar. We'll talk through the modern R&D challenges, the data quality and how it can increase R&D output, how ELN can improve data quality and experiment efficiency, and then we'll finish with a Q&A with Jake and Barney. And throughout the webinar, you can also use the Q&A function to ask all of your questions. All right, I'll now hand it over to the team. Let's get started.
Hi, everyone. So a quick introduction from myself. I'm Jake. I founded LabStep 9 years ago now at this point. My background originally was in biomedical sciences, did various research projects before leaving academia, mainly through frustrations with some of the existing ELN and lab software products that were available, and started LabStep. I've built that over the last 9 years, and then 7 months ago, we successfully sold to Starlims.
I'm Barney, similarly coming from a background in academia, did my PhD in synthetic biology at Imperial, so similarly spent a lot of time in the lab, a lot of frustrations with both paper and electronic lab notebooks at the time, and then joined LabStep about 5 years ago or so, and I've been working with Jake and the team and lots of clients to figure out how we can best use software to make scientists' lives easier and improve the overall efficiency of the R&D process.
Perfect. So I think to start with, we're going to talk about some of the challenges around R&D. And I think at the heart of the problem we're discussing today, it's the fact that ultimately R&D is slow and it's expensive. And I think the stats up here, 84% of research leaders agree that it is critical to reduce their department's product development cycles. And that's not just about cost savings, that's also, can you get faster to market? And the more competitive you can be as a company, the more profit you can drive. So how do we address these? I think when we think about efficiency of an R&D organization, there are 3 main things to optimize. So the first 2, I think, are pretty common to any organization. The individual productivity of each scientist. Can we make their daily tasks a little quicker, a little easier? I think secondly, you have here the kind of interpersonal efficiencies. So how easy is it to collaborate with others? Can we remove the friction and the extra steps that will just waste time or cause confusion when handing work off from one person to another, or getting somebody to pick that work up and carry it forward? And this is compounded, especially in larger R&D organizations. And kind of ELNs are a really powerful tool for addressing both of those first 2 things. And Barney is going to touch on many of the ways later on in the talk. However, the third piece is more specific to R&D, and it doesn't really get talked about that often, but I think it's perhaps one of the biggest potential drivers of efficiency gains, and that is what we're calling experimental efficiency. And it's how efficient can you be with the number of experiments or the number of steps you need to go and reach the same result. Because kind of ultimately, physical experiments are in a lab, they're very costly, both in terms of time and resources. And if you can reduce the number and get the same results, the savings can be huge. And so I think this is a really nice visual. R&D is not a linear process. It's never going to be like manufacturing here at the top. Knowledge is not, it's not like you're producing a car in a factory and you're going from step to step to step. When you journey into the unknown, as you have to in R&D, by definition, you don't know where you're going. You don't know where you're going to end up, and you don't know what you're going to discover. And that's kind of ultimately what we're trying to do. The answer is how to get there. And I think what we want to do and what the opportunity is, how do we get from inefficient to efficient? And kind of the other way of thinking about this is there's multiple diversions and there's multiple potentially unnecessary loops that are being taken in this process. And how can we reduce this? We recognize that there's always going to be questions. It's always going to be innovative R&D, but how can we reduce some of those unnecessary dead ends to streamline that process and make it as efficient as possible? And so I think for this, there are three key sources of inefficiency. And so one is caused by the fundamental lack of knowledge, the kind of intrinsic uncertainty involved in the scientific process. We can start heading in one direction, not knowing the answer we're looking for, and it's kind of in a completely other direction. This is kind of an intrinsic problem at the core of doing R&D, and by definition, you're venturing into the unknown and stumbling in the dark. And so there's not really much that we can do about that, which is why we will always have kind of a few navigational wrong turns in that map. However, there are a lot of unnecessary loops and diversions, and these we believe are preventable. And it's really fundamentally looking at, okay, well, what leads to these? And kind of we bucketed those two unnecessary diversions into two categories. One is human error, and this causes you to then go and have to repeat experiments. And then the other issue is the lack of reproducibility. And so the ability to reproduce an experiment is fundamentally an essential part of the scientific process, especially in a commercial setting where we're not just doing this for experiment's sake and for curiosity. And so I think you can't expect to do something once and then immediately introduce it into your business process without further testing. You're always going to want to be able to go and repeat your successful experiments to validate and confirm that the effect is real. And the problem comes when you try and reproduce something and you can't. And then you have to go back and do more experiments to determine and figure out why it isn't working the same way. Was it because of the science, or was it because somebody made an error, or something just wasn't captured correctly? And that is what we believe can lead to these long diversions away from the optimal path. And then what does this have to do with an ELN? I'll kind of hand it over to Barney, but I think it's kind of very clear that there's a lot of research out there that shows that this lack of reproducibility is a huge problem. It costs research organizations across the scientific industry over 20 billion. And so it's how can we go and really start helping people address this?
Thanks, Jake. So yeah, I think in answer to the question, it kind of has a lot to do with ELN. I think ELN has the potential to drive efficiency gains kind of in all of these ways that you've identified. So yeah, from improving the individual productivity and effective collaboration, there's we could talk at length about that. But what I want to focus on today, because we do have limited time, is this experiment efficiency piece, because I do think it is a little less obvious, perhaps potentially of more interest. So yeah, I'll try and cover in the next section how ELNs can really actually help address all three of these sources. So yeah, certainly the reproducibility problem we'll be talking a lot about, but also kind of human error, and even actually some of this intrinsic uncertainty with doing R&D. I think ELN has the potential to address, which I think is very exciting. So before we kind of dive into that, I want to introduce one key concept, which I think is really at the center of a lot of these benefits of ELN, and that's data quality. So I should probably explain a little bit about what data quality is, and even just what we mean by data. I think when people usually think of data in a scientific context, you're thinking about your plate reader measurements or your NMR spectra or your microscope images, and all of these measurements you're taking to try and observe an interesting effect. But actually, I think arguably even more important when it comes to things like reproducibility is all the metadata around that. So all of the information about how that data set was produced, what the steps were to get there, all the conditions, and all the bits and pieces like that. So when I'm talking about data quality, this is really what I mean is this whole picture. And I'll go into kind of how important all these different pieces can be. But yeah, I really think that when it comes to the quality of the data, there are three really important aspects that are going to kind of lead back into those sources of inefficiency that we've talked about. So I think the first one is the accuracy of the data. And it should be fairly obvious how accuracy is important to something like reproducibility. If you have noted down the wrong temperature or the wrong enzyme that you used in the experiment, then obviously when you come back to try and do this again, you're going to get a different result. You're not going to be able to reproduce that. And so that's obviously something very important that we need to make sure is true about our data is the accuracy. And it might seem an obvious thing, but actually I think in many cases we can have inaccuracies in data with the way things are done at the moment, just because there is often a delay between someone actually doing the experiment and someone writing that up and writing the record. And in that delay, the longer the delay is, the more likely people are to misremember things and get inaccurate data, or just completely forget things, which kind of it brings us on to the second point here, which is that we really want our data to be complete. And this is going to be really important for that reproducibility piece. So what do we mean by complete data? Well, it's a lot, basically. In an ideal world, this is everything we'd want to have access to make our experiments as reproducible as possible. In addition to the raw data, obviously, which we all care a lot about, we also want to know all the method steps followed in the lab to get there. And that includes kind of who's done it, obviously what they've done, but also kind of where they are and when they did it, because all of these things can potentially have an influence on the experiment. Similarly, all the materials that you've used in the course of this experiment, from the exact amounts that you're using, but also the specific batch, the specific lot number, because these things can have an effect when you go and try and do an experiment again, as well as the lineage. If it's something you produced in the lab, it's really useful to know where that sample has come from, in case you have things like contaminations or you realize there was a mistake earlier in the process, to be able to trace that down to everything that it affects. And even like the usage history of all those materials. We know that things like freeze and thaw cycles can have a big impact on some experiments in molecular biology and other fields. So, that's all really important information to capture as well. Then you've got the devices that you're using, your instruments, knowing exactly what model you've used, but also the specific settings you've used on that day, which again can vary from time to time. And like when it was calibrated, when was it last serviced? Again, all things that could influence an outcome of an experiment. And then we have the things that we explicitly control, these variables, like the temperature you used for a particular reaction or the time you leave it for. And then there's a bunch of uncontrolled variables, like the temperature in the lab or the humidity, but things that might nevertheless actually affect the outcome. And so these are all really important things that need to come along with the raw data for this complete picture. And the final one that I want to draw your attention to, because I think it's very often forgotten about, are the analytical methods. Because very often, the result of our experiment isn't the raw data. It's actually been processed, or you've calculated the significance, or you've taken an average. And increasingly with modern science, these methods are tend to be more and more complicated. There are more and more variables and things that could change, or different statistical tools to use. And so if you don't kind of keep track of exactly how data was analyzed, then again, it can make it hard to reproduce. You might get a different result and then spend ages doing more experiments to try and figure out why. But it was actually just because you used a different statistical method. And if you'd known that in the first place, you could have saved yourself a lot of time. So hopefully it's clear that if you've collected all of this data about how you're doing your experiments, you're much more likely to be able to go and reproduce it when you need to, and you're much less likely to have to go on a diversion to repeat it. But even if you do get a different result and it's not reproducible, having all of this information really narrows down the kind of scope of things you have to troubleshoot, and you can really start to potentially see, oh, well, maybe the difference was down to like the time of day it was done or one of these uncontrolled variables, and you can kind of, again, reduce the number of diversionary paths you have to take, and it will just make your whole R&D process more efficient the more of this data you've collected. So the final aspect of data quality, which I want to talk about, is how structured it is. So what do I mean by structure, and how is it useful? Well, to kind of give an example, if we could have a really accurate, really complete record of everything we did in a bunch of paper lab books like this. And if it's all trapped in here, then there's not much we can do with it, and it's not really much use to anyone, apart from, you know, going back and reproducing that exact same experiment. In contrast, if we have our data in a more structured format, in a database, relational database, or other kind of structured formats, then now we can start to think about using this data, feeding it into some statistical models or AI, machine learning, and actually using some of that data to make future predictions about our science. So to kind of give you an example of what I'm talking about, I'll take one from molecular biology, which is obviously my past life. So in molecular biology lab, you'll be doing hundreds of PCRs a week, sometimes even a day, across lots of different members of the lab. But when we did it, you know, all of this data about what primers we used, what annealing temperatures, etc., was just scattered in different people's lab books. Even if they were using a digital lab book, it wasn't structured. It was just disconnected from everyone else's. Whereas if we had this in a structured database of every single PCR we'd used and all of these conditions for different primers, we could feed that into a pretty basic statistical model. We don't even need to get into fancy AI and machine learning things. We could use that to better predict when I next come to do a PCR with this set of primers that we have in the lab, what's most likely to work. And, you know, that can then just cut down the number of these, you know, extra paths we have to go on to optimize conditions for a particular reaction, and a lot of this manual troubleshooting that goes on. And if we're using that data, that's our data, that's the real data from our lab generated over years, it's going to be much more accurate, much more applicable, because it's in our hands. It's using the exact setups that we use and the devices we use, as opposed to, you know, aggregated data from a kit manufacturer or anything like that. So I really think this has a huge amount of potential if we use all of this data to make better predictions, to allow us to take these much more kind of linear paths. As Jake said, we're never going to eliminate dead ends and diversions completely, but we can definitely, there's room for improvement to do less experiments and really lower the cost. So yeah, I think all labs are kind of sitting on this gold mine of historical method data, of the hundreds and thousands of experiments that they're doing, that could potentially be used to inform predictions and actually design better experimental routes for future experiments. But at the moment, it's kind of locked down in this form that it can't really be extracted, it can't really be used. And that's really what we want to move away from. So I think this kind of brings us to the end of the data quality discussion and onto ELNs. I think it's clear from this, hopefully, that really documentation has to sit at the center of the R&D process, all the way from this kind of planning stage to the execution stage where you're actually doing the experiment and making observations, and even that analysis stage and reporting stage. All of this kind of needs to be documented, and it's has this super important role. But then if we kind of look at the current state of lab documentation and the tools that people are using, we haven't really come a huge way since kind of the 1800s, when the dawn of formal science. And back in 2017, there was a study done that showed that 90% of scientists reported to be still using pen and paper, which is crazy. And I mean, I like to think that since then, and since the introduction of LabStep and other kind of similar modern ELNs, this number has improved somewhat. But even anecdotally, we know that most of the people coming to us to use LabStep, they're coming from paper, and there's still a ton of labs kind of working in this way. And I'd actually argue that the lab book in the 1800s was actually a better quality data than in 2017, because in the 1800s, this lab book contained all of the observations, every single data point. It was all written in this one book, because that's how they kind of did science, and you could do that. So it really was a complete data set, a complete record. Whereas if you fast forward to 2017, we're still recording some methods and such on paper, but most of the data itself, the outcomes of that experiment, is going to be digital somewhere on some computer, on a memory stick, or as an attachment in an email to somebody. And so it's really become quite fragmented. And the best you can hope for is that someone will print out a graph or something and stick it in the book. But even then, again, you're missing that analysis that was done. That's probably somewhere else in an Excel spreadsheet or in a Python script on someone else's computer. And so, really the data quality has actually gone down, I would say, which is partly what necessitated the introduction of ELNs in the first place. So they came to the fore in kind of, I guess, in the 90s, the first ELNs. But these early ELNs were essentially kind of a digital version of a paper notebook. So, it's just a place where you can write down exactly what you've done. It just happens to be digital, but it's still not really structured. And this brought a lot of benefits. I mean, just straight out of the box, if it's digital, it's easy to back up. You can access it remotely. You can search it, which is obviously way more difficult on paper. It's much easier to collaborate on these things, much easier to kind of organize and manage them, and monitor things like compliance can all be kind of automated. So it brought a host of benefits just out of the box, the early ELN technology, but it didn't really address the data quality issues. It didn't really improve the efficiency of R&D at all. And I think the reason for this, or the kind of the core problem with these early ELNs, is that they actually increase the documentation burden on the scientists. So, they were quite often clunky, hard to use. Like scribbling stuff on paper is actually quite easy compared to typing things up. So they actually made it a bit harder to record some of these details and some of this record. And if it's harder, people are going to do it less. And so again, that data is going to be less complete, and potentially less accurate if it increases that time scale from when you actually do the experiment in the lab to when you do write it up in your ELN. if that's been a week or so since you actually did it, you're more likely to misremember things or make mistakes. And so that's why I think we haven't really seen the true benefits of digital technology in the R&D space. But I think we've come a long way since then. I think modern ELNs do a lot to kind of address this, which is really what we want to talk to you about today. So, and really they do this because they've become a lot more than just a basic notebook, and they have a lot more depth of features to address a bunch of this stuff. So, I mean, I'll give examples from LabStep, but a lot of these stuff you'll find in other modern ELNs. Probably not all of it together, which is what we think is great about LabStep, but you can take each of these points on their own to some extent. So the first thing is having kind of an integrated protocol library of SOPs. So I think this does a couple of things. Firstly, these at least our kind of protocol execution system. It's optimized for use on mobile devices so that you're at the bench following these protocols, which is going to reduce human error just to make sure you're following things step by step, which is obviously one of those sources of inefficiency. But almost more importantly, these protocols can also act as a data collection form. So in this example, you can just click to enter the temperature that you've used. And so this is making it much easier for scientists to actually record some of this. It's smoothing out that process by using templates and shortcuts so that they have to really enter the absolute bare minimum amount of information and not kind of have to rewrite out repetitive things or use full sentences, which you kind of need to do if you're writing things out by hand. And like I said, it's also kind of real time at the bench to, again, reduce that time between actually doing it and writing it up to improve the accuracy of that data. The second piece is you'll often find a modern ELN will have an integrated inventory system. So this really allows all of that data we talked about for the materials you've used, the samples, the reagents, all that metadata associated with it, the history, the lineage of these things, to be attached to your experiment record with like a few clicks, or even just by scanning a QR code, so that it's super streamlined and super easy to collect this really complete record of everything that's gone into your experiment. You'll also often find that these come integrated with like an order management system, so you can request another batch of an enzyme or chemical that you use, which again, doesn't have much to do with the reproducibility piece, but it comes back around to just enhancing that individual productivity and streamlining the collaboration between people in the lab. You also have kind of an integrated devices module for the most part, which again, similar to inventory, you can really quickly link it to what device you've used, again, using QR codes if you want. And that's going to keep track of all the metadata of the device you've used and its service history, its calibration history, giving you like a really complete data set to improve reproducibility. It also gives you the opportunity to kind of really streamline things by integrating the device itself and just fetching the data from the device at the click of a button, which really reduces the burden on the scientist to do things. So make it much easier to capture the settings the device is used, for example, and just reduce the chance of that data that you might put on a memory stick or email to yourself. Yeah, reducing the chance of that kind of going missing and losing that link to this record of the exact methods used to produce it. Again, you usually get a few kind of productivity and collaboration features just to make life a bit nicer. So being able to like book devices and things like that, you'll often find in a modern ELN like LabStep. Yeah, the final piece is, again, I think really important. This is something I think only we're doing at the moment on LabStep, but I'm sure other notebooks will follow suit. which is actually integrating the analysis component of the experiment. So we have these reproducible code capsules that you can embed in protocols or in your notebook entries, which allow the code to kind of just be run at the click of a button and just use the data that you've also attached in your notebook entry. So again, this just keeps everything in one place so that you're not losing track of how the data was analyzed, but it also just makes life way easier and way more streamlined rather than sending the data off to a bioinformatician or anything like that. So, and then when you come to reproduce it, you can just rerun it again, and it's super easy. There's no need to kind of faff around trying to set up your local environment with the right version of Python or anything like that. So I think that's another really powerful tool that can really streamline things. And I think a kind of a common thread for all of these four pieces is the presence of features that really reduce the burden on the scientists when it comes to the manual data entry and how much effort it takes to keep track of all of this stuff that makes up a kind of a complete record of the experiment that was done. And I think it's important to emphasize this because it's not so much about saving time, although it does save time, but it's often not the difference between it taking 2 seconds to do in an ELN and taking 2 minutes to do by hand. Often, if it takes 2 minutes to do by hand, it just won't be done. And so it's usually the difference between these details being collected and them not being collected at all is what we're talking about. And that's why it's really important to reduce this burden, because it really ties into the adoption of the tool and how much it's actually used, which is what's going to have this big impact on the overall reproducibility and also, how complete this data set is and how well it can then be used for predictions. Which brings us to the final point, which is about the structured data. So again, this is something that you'll find a lot of modern ELNs are moving more towards this world of collecting this data in a more structured way, using things like the data fields and the form fields that I showed earlier, to just make sure that this data is actually in a form where it can be reused, and making sure there are APIs and things like that so that it is interoperable with other systems, and is in a form that you can actually then reuse that and feed it into some models to make some predictions. So we've covered a lot very quickly. I want to take a moment to just give a bit of a summary, an overview. So Jake talked to us about the factors that affect R&D efficiency, being the individual productivity of your scientists, how effectively they can collaborate together, but also how efficient this kind of experimental pathway is, how many diversions there are, how many loops and repeats you have to do. We looked at the drivers of that, being human error, being kind of reproducibility, how easy it is to reproduce your science, and then also the uncertainty, or to flip that, how well you can actually predict what's going to work and which path is going to be most direct. We then talked about how data quality can drive the efficiency, so how the accurate and complete data can improve your reproducibility, and how having complete and structured data can improve your predictive ability. And then we covered briefly some of the ways that modern ELNs really improve this data quality. So the big piece being kind of making things easier, reducing that manual entry burden, but also reducing that time to capture, so making things real time, and finally centralizing everything and making it structured so that it can be reused. So I'd like to finish just with this kind of visual to think about when you are kind of looking for an ELN or thinking about what system to use. I think at the base of this pyramid, you've got all of your ELN basics that are obviously super important, that again, most ELNs are going to be doing, allowing you to access it remotely, being able to back it up, your data security considerations, your compliance piece, and just easing collaboration a bit and allowing things to be searchable. That's kind of the fundamentals of ELN that you're always going to get. And then I think it's important to start thinking about this reproducibility question and asking yourself, how easy is it going to be for my scientists to kind of collect this complete and accurate data? Are we covering all those bases? And what is the burden on the scientist? How can we minimize this? And for this, the usability is really key. I mean, you can have all of these features that we've mentioned, but if people don't use them, then it's kind of pointless. So it's really important to make sure that the system is usable so that people will adopt it and they use it, and the data does end up being complete and accurate. Because if it's not used, then again, you might as well not have it. And then the kind of the pinnacle is to start thinking about, again, this predictive potential. Is the data going to be in a form that we can use to kind of generate insights and make predictions? Is there an API that we can use so that we can start plugging systems together and actually making use of the data, or is it just kind of locked down into one system? So yeah, those are kind of the things I just want to leave you with to consider. And then now I think we've got some time for Q&A.
Right, thank you so much, Barney and Jake, for going through this topic with us today. So with that, we'll start the Q&A. So if you have any questions, please don't hesitate to use the Q&A function, and then we'll have Barney and Jake sort of answer them. Okay, so here's a question from the audience. So one challenge we have with data quality and completeness is getting people to adopt a new tool. Why do you think that is such a challenge, and what is your recommendation to get more adoption?
Yeah, I think I touched on it briefly, but I think, the reason that ELNs have had poor adoption in the past is simply because they've been harder to use. Like, scientists are busy people, there's a lot they want to get done, and if it's adding friction to their workflow, if it's going to be harder to actually use day to day than just using paper, they're just going to default to either just using paper or taking shortcuts and not using it correctly in the right way. So yeah, I think that's why this usability piece is so critical. I think something else I'd add to that is this adoption piece. It's also becoming like a kind of a recruitment problem as well for some companies, in that young people really expect to tools to work in a certain way and to be usable. There's quite a high standard of usability in the kind of personal tools they use day to day, the Google products, Microsoft products, etc. And so being forced to use some of these antiquated ELNs, people don't want to do it. And I think this problem is only going to get more acute as we go forward. And so I think it's really important that ELN as an industry keeps up with that and is kind of really easy to use and is kind of up to modern standards of usability.
Yeah, I think just to add to that very quickly, I think it was one of the central kind of problems that really started the LabStep journey, is that I'd seen time and time again these large organizations that had tried to implement a solution and hadn't got adoption. And to echo what Barney said, it was because people were used to every other aspect of their life. They had a super slick mobile app. And so really from origination, LabStep tried to go and solve the adoption problem as much as layering in huge amounts of feature-rich functionality that may tick the boxes on a RFI, or kind of may tick the boxes in terms of the feature requirements, but don't actually get people using it on a daily basis, which is ultimately the most important thing. And I think that our success in both academia where it's an individual researcher that's making that decision and our ability to spread very broadly there, but then also how we've been able to go and expand and get really good adoption within larger organizations is testament to the fact that it's a very astute observation. It's something we recognized and something we've really been trying to proactively address.
Amazing, thank you. We have another question. Is there still a need for structured data in the world of LLMs?
Yeah, I think this is a really interesting one. It's definitely something we've been thinking a lot about at LabStep, and the last year or so, obviously with ChatGPT and the rise of these large language models. I think there's a huge amount of potential for LLMs to be really useful in this space. However, I think structured data is still really important. So because fundamentally science, you always need to know kind of the statistics. You want to have a confidence interval, and you kind of need to be able to show you're working. So, an LLM might be pretty good at kind of predicting an outcome almost qualitatively, but I think if you can't kind of back that up with statistics, then it's not as useful in the scientific sphere. So I think where I see LLMs playing a larger role is in actually helping to structure the data. So if you've got a load of unstructured data, a load of unstructured notes, you can use LLMs to actually extract from that the structured data points and feed that into your database. And then once it's in the database, then you can do proper statistics on it. And then you can see, okay, there's a 10% chance of this result being due to chance. So yeah, I think structured data is still going to be important, but I do think LLMs will play a large role in ELN moving forwards.
Amazing. Okay, we have another question. So how do you recommend people get started fast? This seems like an overwhelming this is a bit overwhelming about how data can be collected.
Yeah, so I think, again, this is something that we're very aware of at LabStep and has kind of informed the approach that we've taken with the product. So, and again, I think it's a mistake that has been made in the past with some ELNs and some other platforms, is requiring too much upfront. So the approach we've taken at LabStep is to allow you to kind of progressively add these layers of structure to your data. So from day one, you can just use LabStep as a basic notebook. You've got a page, it's very familiar, looks like a Word document. You can just write everything in there just as you would if you were using Google Docs or Word. And then we can kind of progressively move people towards starting to adopt the inventory. You can highlight text in the document and say, oh, actually, this is a piece of inventory or links to a sample, or you can progressively highlight some, temperatures and actually link that to a structured data field. Same with your devices. So you can kind of progressively increase the level of structure that you're using, and you don't have to kind of have everything set up from day one for it to work. So yeah, I think this transition from more traditional ways of working is really important, and it is another facet of that adoption problem. Is you have to provide a smooth journey from where we are to where we want to be. You can't just on day one try and get everyone to put stuff in a database. It's just not going to happen. You need to make it very familiar and then allow the structure of the data to kind of then be introduced over time.
Great, thank you so much. I guess we'll wait a couple extra minutes to see if any other questions are being asked in the chat. Yeah, in the meantime, Barney, Jake, do you have anything else that you want to share with our audience today?
I think one thing that I didn't get around to covering much was the human error piece. So again, it's one of these things that can lead you down a rabbit hole. And obviously the later you make the mistake or the later you catch the mistake, then the more work has to kind of be repeated and the more waste it can lead to. So, I mean, I touched on how having a kind of protocol execution system can try and reduce that error by surfacing information exactly when people need it and letting them know bits and bobs. But I think actually the data quality can feed into this as well. And it's not something that is happening very much at the moment in the industry, but I think it's a real potential place for growth in the future, is actually using this data, all this structured data we collect, to try and catch errors earlier and prevent errors earlier. So, I mean, some basic examples is, yeah, things like alerting people if they're using a reagent that is out of date, or that if the device they've used, if the results are starting to kind of trend off and it might be implies that it needs to be recalibrated earlier. All of this, these kind of things, I think there's a lot of patterns in the data that could potentially help catch errors earlier, that people aren't making use of at the moment. So that's a kind of exciting area that I'm excited to see happen more in the future.
Great. Okay, so we've got a couple of questions in the chat. So the first one, I'm interested in how the code capsules work and the attached data around that. So does the data need to be in a specific format/structure for the code capsule to be able to run it? Can the code capsule be cut and pasted around?
Yeah, so the data doesn't have to be in a specific format. It can just be a file. The code capsules, at the moment, they run Python. So as long as there's, that data can be processed in Python, then it can be processed on LabStep in the code capsules. We're in the process of supporting other kernels like R. But yeah, essentially it can be any kind of data file. And yeah, the capsule knows which experiment it's being run in. So it essentially, it can fetch the data from that experiment. You can kind of say, get me the current experiment and then get me this particular data field from it. And then you can work with it, and then you can even push that data to a different data field on the experiment to kind of produce a plot or an outcome number or anything like that. So yeah, that's kind of how they work. Can the code capsule be cut and pasted around? Well, yeah, I mean, it's at the end of the day, it's code, so it's text, so you can just copy it and then paste it into another code capsule in another experiment. But obviously, the whole point of these is that we advocate them to be put into protocols themselves. So it's just a part of every single time you run the same type of experiment, you run the same type of analysis, and you can just hit run. But if you want to copy it and do a variation of it, then yeah, you can do that.
Wonderful. Could you tell us some stories about existing customers, any use cases that we could share with the audience today?
I mean, again, broadly, it's a very difficult question to answer because we have such a wide, diverse kind of segment of people in different industries and areas. So we have your classic R&D, drug discovery, pharma companies, and we've got some great examples of teams of chemists working with biologists. And yeah, we've got great examples of companies doing entire rollouts of LabStep, then starting to leverage that structured data to be able to go and train AI to optimize and accelerate their R&D. We have plenty of specific case studies. So if people are after specific case studies, then I'd recommend you get in touch with the sales team or the marketing team, and we can then follow up with some specific case studies or user stories from your specific industry and area that may be more relevant to you.
Thank you. Okay, another question. Is LabStep ELN able to scan both 2D and 1D barcodes? Which library does it rely on?
We kind of have different solutions for both. So yeah, there's a 2D barcode scanner kind of integrated into the web app itself. I don't know off the top of my head which library we use. Some React QR code scanning library. For 1D barcodes, what we what we suggest people do is just use a normal barcode scanner. So we don't have one integrated into the app, but if you have a barcode scanner plugged into that you can connect to a tablet, or if you've got it plugged into a computer, then yeah, if you scan the barcode field, it will just input that that code into the box on LabStep that will then pull up the specific sample that matches the barcode. So yeah, there's ways to work with both. It's a little bit more streamlined with 2D, but it's not a huge difference.
We also have built-in QR codes, so that if you use the LabStep QR codes, that's actually kind of innately built into the platform.
Someone is asking about way to calculate ROI. Yeah, we get asked this a lot. I think calculating ROI is very challenging. And again, you can only really do it if you've already collected a lot of data about the kind of experiments you're doing and how much time and money you're spending as a kind of a baseline before you start using LabStep. But if you're collecting that kind of data, then obviously it's then a lot easier to see if there's a shift once you start actually using an ELN. So but yeah, the problem we have with most of our clients is when they start using it, they have no idea what they've been doing in the past, so it's then harder for them to calculate. So yeah, it can be a tricky one if there's not that baseline data to compare against. There's a question about structured data. But yeah, maybe it's about extracting more structured data from images which are inherently unstructured. So yeah, again, with something like LabStep, we have an API. So anything that you can't do in one of our code capsules in Python. So if you can process the image data in a code capsule, then do that, and then write the more structured data to the data fields in LabStep. I'd advise that. If you can't, if you need to use more advanced software, then yeah, I'd just advocate using the API for that, so that you can just say, okay, we've got this data in, and then have that system send an API request to LabStep with the results.
Okay, it looks like we're going to have to wrap up time-wise. What we'll do is, if there's any outstanding questions, we can respond to them via email, or please get them to email marketing@starlims.com. But thank you so much for all your time. We really appreciate it. We hope that it was insightful. Yeah, and thank you so much, everyone.
Yeah, thanks everyone.
Bye.